you might just want to speak.
That's
Okay,
true as well.
are we good to go?
Good to go.
All right, great. Hello, everybody. Thanks for joining us this evening. Sorry for the delay. A couple of technical snafus here trying to get going. This is the session on using Mercurial version control with Visual FoxPro. The nice thing about being an independent developer is that I get to choose the tools that I work with. One of the tools that I like, besides, of course, Visual FoxPro, is the Mercurial version control system. I know when Todd did the quick survey of some people to see what interest there was in various topics, about 40% of the respondents said they were already using a version control system. I don't know how many are using, how many of you who are here tonight are using version control at all, much less Mercurial specifically. But this session is going to be introductory, so we're not assuming anything. We're going to start from scratch. If you've seen version control before, this may be a little different. If you've seen Mercurial before, this will be a little bit of review. What I want to cover tonight is mostly about how to use version control and Mercurial specifically, but before doing that, I wanted to talk about the why, and that was kind of in response to a question that Todd posed. You know, let's talk about why we would want to use version control in the first place. Then I'll show you how to install and configure Mercurial, which is very simple. We'll spend the bulk of our time on working with Mercurial and then using it with VFP specifically. So that'll be the meat of the session this evening. We'll wrap up with a couple of comments about remote repositories and how to interact with them, how to create them and configure them. A couple of comments on strategies that you can use if you're working with a team. And by the way, this material is as relevant for the solo developer as it is for teams. And I'll finish up with a couple of suggestions to help keep everybody out of trouble. So that's where we're going this evening. And to get us started again, I wanted to talk about the answer to the question why. Why use version control? Why use distributed version control specifically? And why use Mercurial out of all the DVCS or distributed version control systems that are available? The answer to the first question, why use version control at all, is that it creates a permanent record of every change to every file that you track in the version control system. So back up a minute and think about when you're not using version control. How do you back up your source code? Most of us typically years ago adopted the father, son, grandson type of generational backup system. And maybe we kept 3 of those or 4 of those or even 5 of those, but there was some finite number of those backups, and then you typically recycle the backup media, whether it was a zip drive back in the old days or a thumb drive or whatever it is. You only had a finite number of those. If a problem occurred early on in the development process and wasn't discovered until later, you might very well have all of your backups have a bug in them and not have access to an earlier version before the bug was introduced. So one of the nice things about a version control system is that it is in fact a permanent record of every change to every file. And that creates the opportunity to use it kind of as a time machine. I don't know how many remember the Rocky and Bullwinkle show, but I kind of grabbed this slide for the time machine. But in any case, what the history, the permanent history of version control system provides, allows you to go back to any point in time and see what the file looked like. And not only to see what it looked like, but to compare what it looked like then to what it looks like now. So imagine if you had a tool that would allow you to see what the software or the source code looks like now and to visually compare it to what it looked like then and to quickly spot the differences. And in fact, beyond that, to be able to merge changes in from 2 different sources if that becomes necessary. In addition to the ability to use it kind of as a time machine, a version control system enables you to easily do what I call multi-track development. And it's very similar to a train yard where you have multiple parallel tracks and switches connecting the various tracks. I think that analogy holds up real well for multi-track development. The idea there is that you as a solo developer working on 2 or more versions of the same product, or if you're working with a team where different team members are working on different features, can develop in parallel and then merge changes together at the appropriate time before doing a build. So for all of those reasons, for the permanent record, for the ability to go back and compare changes, and for the ability to work on different features separately in parallel and then come back and merge things together when it's time to build, all of those things are provided by a version control system. So in a nutshell, I hope that answers the question about why you might want to consider using version control of any kind. Let's talk about the different kinds of version control systems briefly and why you might want to choose a distributed system. The other kind is called centralized, and in the centralized system, the basic concept for all of these systems is the concept of a repository, and a repository is nothing more than the physical set of files that store the change history for all of the source code. In a centralized system, there is one repository, and all of the developers who are working on that system interact with that same repository. Typically, in a centralized system, there is the concept of checking out and checking in a file. And if a file is checked out to developer A, then developer B can't check it out and work on it. So that's a limiting factor, because it may very well be the case that two developers or more need to work on the same source code file, even if they're working in different parts of it. In a distributed system, on the other hand, each developer has his or her own local repository. So this person down here has one, and this person has one, and this person has one, and these people have one, and everybody has their own local repository. It's called local because it exists on your local hard drive. And the nature of a distributed version control system is that every developer can, if the business policy and the office policies allow it, interact with each other directly. And so that opens up a huge advantage to sharing and collaborating on changes with one another in a team environment. So that's the nature of a distributed version control system. Reasons, again, you might use a DVCS is that the local repository eliminates the dependency on a central repository. I used to use a centralized version control system. And there were times when my connection to the repository, which was in Kansas City or someplace remote to where I am, was unavailable. And so I was stuck. And I'm sure many of you, if you've used a centralized system, may have had the same situation. A local repository on your local hard drive means you don't have that dependency. If a connection to somebody else's repository is unavailable, that's a temporary situation. You can still work on the files and interact with your repository. The other advantage is that it is fast. Because you're working with a local repository on your hard drive, that's a very fast process. So the concepts of getting a file or committing a file back to the repository is much quicker than it would be if you're going across the wire or across the network or across the internet. Why Mercurial specifically? And by the way, the HG symbol, which is the chemical symbol for mercury, is used as an abbreviation in Mercurial. So you'll see that pop up when we start talking about the commands. Why would we want to consider using Mercurial specifically? A couple of reasons. First of all, it's a very easy install on Windows. It actually comes in as a Windows installer. It's updated frequently. I'll show you a little more about that later. So you download the MSI file and you install it. You get automatically with it the Tortoise HG shell, which is the graphical user interface to Mercurial. It comes with it in the same package, both installed at the same time. I found Mercurial to be very reliable. I wouldn't say other systems are not reliable. That isn't a comparison. It's just to say that I found Mercurial to be a very reliable product, and it's free. So are some others, but all of these things are going in favor of Mercurial. I would be remiss not to mention Git. Git is similar in many ways to Mercurial. Git is also a distributed version control system. It is popular these days, and many people use it. And if you are inclined to try it as well as Mercurial, you can install both of them at the same time on the same machine. They can coexist, so you can play with one and the other and kind of see which one you prefer. One thing I will point out is that when you look at the size of the install, although neither one is very big, Mercurial comes in under 100 megs, where Git comes in about 4 times that size. It's not a big consideration. The number of files is considerably higher. Again, neither one of them is huge, but it is something to be aware of. So installing and configuring Mercurial is a very simple process. You are going to install a package that gives you both the Mercurial product itself, which is actually a command line product, and we'll talk about that in a minute, and also the Tortoise HG package. You'll download this from this website, tortoisehg.bitbucket.org, and when you go to that site, you'll see this screen. And what you have here is a download link over on the right. Can somebody who can speak tell me, are you seeing my mouse pointer on the screen here? Okay, I'm going to assume that perhaps you're...
Yeah, we can see that.
You can see it. Thank you, Todd. When you go to this screen, you're going to see over here the download link. And if you're running on a 64-bit machine, which I was when I grabbed this screenshot, you're going to get a download for the 64-bit version of Mercurial. Down below that then is a link for the 32-bit. The situation will be flipped if you're on a 32-bit machine. You're automatically going to see the link for the 32-bit download with the 64-bit down here. Over on the left is the release history going from oldest at the bottom to newest at the top. And you'll notice that this product is updated about once a month. It's a very actively maintained product. When we get to the end of the session, I'll give you a slide of resources, and one of them is a mailing list forum you can subscribe to, and it's a very active forum, thousands of messages over the last year or so that I've been subscribing to it. So downloading is simple. One thing to point out when you install it is that if you're installing on a 64-bit machine, the 32-bit extensions, which are marked as x86 on this slide, are not automatically installed. That may not be a big deal, but in my situation, I use a 32-bit Windows Explorer replacement called PowerDesk. PowerDesk is a 32-bit application, and because the Tortoise HG shell uses overlays, icon overlays, to show when files are out of date or up to date, you need to install the x86 extensions as well if you want it to work with a 32-bit app on a 64-bit machine. So just a little tip there, if you're doing that, to turn on that x86 extensions and include that in the installation. Configuring Mercurial is dead simple. There's really only one thing you need to do. There's a global user file called mercurial.ini that is created when you install, and you can edit that thing directly. The way you'll probably do it is through the Tortoise HG interface, which we'll show you in just a few minutes. But the only thing that's really required is that you identify yourself to Mercurial, and that's so that if you're interacting with other users and you're committing changes and they are committing changes, that the repository has a record of who committed which changes. And so it's a very simple, it's an INI file. In the UI section, you create the username entry, and the typical format, although there's no hard and fast rule, is first and last name followed by an email address. There is also a project level configuration file called HGRC. Again, you typically don't interact with that file directly. You can add it through Tortoise HG. And that file is used to override your global settings. So you might have global settings for defaults, and then for a particular project you might override that. Spend a few minutes here on the basics of Mercurial before we get into the details of working with it in VFP. The fundamental concepts are the working directory and the repository. So on the left here, what I'm showing is a hypothetical Visual FoxPro application with the typical folder structure, or at least atypical folder structure. The only thing unusual about it is this .hg file or folder here, which is actually the local repository. So the working directory, which is just the Mercurial's name for what we would otherwise call the Visual FoxPro project folder. And in this example, that's my app somewhere on your local file system. Another name for the working directory is the working copies. You'll sometimes hear both of those used interchangeably. The local repository, again, exists as that .hg folder underneath your working directory root folder. In a Linux system, folders that start with a dot are hidden. On a Windows system, they're not hidden. They just show up as every other file or folder does. So you'll see them, but you're not going to do anything directly with any of the files in that folder. Along with the concept of a local repository is the concept of a remote repository. And the definition of a remote repository is any repository that is not your local one. with respect to the same project. So if there are other developers working on my app, for example, you might be sharing a central repository somewhere on a file server, hard drive, let's call it F colon, and you might also be able to access a central repository over HTTP. That's a built-in feature of Mercurial as well. So there are a number of ways to get at them, but the thing to remember is that a remote repository is any repository that's not your local one. So if two developers each have a local one and they share with one another, and I use Bob and Carol as my two favorite hypothetical developers, Carol's repository is remote to Bob and Bob's is remote for Carol, and vice versa. Again, concepts to keep in mind as we go along. Mercurial tracks files, not folders. So when we get started with this, we're going to tell Mercurial which files we want to track. And when we're working with VFP, that ends up being not a trivial decision. What Mercurial stores in the repository are called Changesets. And a change set is basically a snapshot of the files that are being tracked as of any given point in time. Change sets are identified in two ways. They have a revision number, which starts at 0 and just goes up from there, 0, 1, 2, 3, 4, and so on. And revision numbers are local. In other words, they're unique within a local repository, but not necessarily across other remote repositories for the same project. Change sets also have a thing called a change set ID, which is global. And if the same revision has a different revision number in two different repositories, it'll have the same change set ID. That's what enables Mercurial to know whether that change set exists in both repositories or not. In this next series of slides, what I want to do is kind of build up from the bottom the concept of how the change sets evolve as you commit different changes to the repository using Mercurial. It's customary to start from the bottom with these things. You'll see that in most of the books and documentations. So that's the way I'm going to do it here. And I'm using the notation we had in the previous slide, where the first commit is revision 0, and it has some arbitrary change set ID. Any change set that doesn't have a child change set is called the head. And the most recent change set in a repository is called the tip. So again, a couple of terms to keep in mind. As you go along with changes, you're going to be doing multiple commits to your repository. And as you do that, as I show you here, the head will move, or the revision that is identified as the head will be the most recent one that doesn't have any children of its own. So I mentioned this concept of parent-child. In this example, revision 3 is the child of revision 2, and 2, on the other hand, is the parent of revision 3. So there's this hierarchy concept that goes on when you're working with these repositories. And that becomes important when we start talking about the ability to have multiple heads in the repository and the need to do merges and that kind of thing. So if we create another change set off of change set 3, in other words, we've made 3 or 4 revisions to the file, we now make a 4th revision and we commit that and becomes revision number 4. That is now the head and also the tip. But if we go back to number 3 and make a different change and then commit it, then we now have 2 heads in the repository, both of which have the common parent of revision 3, both of which are heads. In this example, both 4 and 5 are heads, but there's only one tip ever. And so again, the most recent revision is called the tip revision. And you'll see these terms pop up in other places as we work with Mercurial. Mercurial is a command-driven language. When you're working with Mercurial, you're actually working with a file called hg.exe in the folder where it was installed when you ran the installer. And if you interact with it from the command line, you can get access to every feature that Mercurial offers. You're not typically going to do it that way. As Visual FoxPro developers, we're used to a visual IDE, and you're going to end up using the Tortoise HG shell for most of your work. But I think it's important to understand that when you do that, when you use Tortoise HG, that it behind the scenes is actually talking to hg.exe, the Mercurial executable, and issuing these commands with its various options. So, for example, if you type in hg space version, hg again being the command for any of these things, Mercurial will respond and tell you what version is installed. If you type in hg help, you'll get a list of all the commands that are available. If you type in hg help followed by the name of a command like add, you'll get help for that command. Now there are other help files as well. There are online ones. There's a PDF of a book you can download. Again, these resources I'll mention at the end of the session. But again, just so you know, and by the way, I use this sometimes just off to the side. I'll open a command prompt and do a quick check of the help file, because it's sometimes easier to do that than it is to go searching through the online ones. In any case, what I want to present to you next is about 15 or 16 commands that you need to be familiar with. You're not going to remember all of these. Don't worry about that. But I want to expose you to the terminology, because it'll come up in the rest of the discussion. So if you're making notes, fine. I know this will be online or recorded, so you can go back and see it again. But you'll want to remember these, or at least become familiar with them over time. The init command creates a repository. The add command adds files, or tells Mercurial to start tracking files. The commit command tells Mercurial to store a new change set to the repository. So if you remember nothing else from this session, please remember those three commands. That's your basic commands for working with Mercurial. And whether you do it from the command line or from Tortoise HG, those are the commands and the corresponding actions, more importantly, that you'll use to actually start using Mercurial with your project. If you want to know what files are being tracked, you can do something called the manifest command, and it'll list the files for any particular revision. When you're working with your working directory, you'll use the update command and the merge command. That affects the files in your working directory. In other words, that's your actual source code files, your PRGs and your SCXs and all of those files. If you want to know what's different between two revisions, you can use the diff action. You remember the slide where we had the apples and the oranges? The diff command is what you would use to show you that kind of difference. The log command shows you the revision history. We'll see this in graphical form in just a few minutes in the Tortoise HG shell. Branching is done through a couple of commands that allow you to create and name branches and to find out what branches exist in a repository. And you can also apply English language names to things, to particular revisions, so that you can refer to them by something meaningful like version 1.0 or release 1.0.2 and those kinds of things. And there's two ways to do that with tags and bookmarks. So again, I know we're exposing you to a lot of terminology here that you're not going to remember right off the top, but at least you will have heard those names as we go along. When you work with remote repositories, the first thing you'd probably do is to clone. And a clone, as the name implies, creates an identical copy of some other repository on your local hard drive. Once you have a clone of a repository, you can then push and pull changes from yours to the remote one. So a pull brings changes in from a remote repository back to your local one, and a push pushes changes from your local one out to somebody's remote one. Before you do pushes and pulls, it's usually a good idea, in my opinion, to kind of check and see what's about to happen before you make it happen. And the incoming command and the outgoing command are used for that purpose. This is what the Tortoise HG shell looks like. And we'll see this in actual use here in a few minutes, but there are several parts to this. It's a really nice piece of work, and actually each one of these sections here is its own little application, which we can get at separately. That's kind of a neat feature. We won't do that tonight, but that's kind of the way this works. Over here on the left is this thing called the repository registry. And what it is, not to be confused with the Windows registry, it's just a way that the Tortoise HG shell allows you to add repositories that you're interested in tracking. Whichever one you have selected here, in this case I've selected one called Bob, that determines what you're going to see over here. This is called the revision history. It's the equivalent of the log command that we talked about earlier. And again, we'll see this in example, but the parts of this pane here are the graphical representation of the history, the revision number starting at 0 and going up one by one, and the branch in which the commit was done. We're not going to talk about branches too much tonight, and then a description of the changes and who did it and so forth. Across the top are several toolbars. The one that's most important is the task toolbar here, and depending on what you have selected here, that affects what you'll see down in this task pane. Right now we have the revision history dial or button selected, so that's what we're seeing down here. Up in this area, you'll notice actually there's a toolbar that's not shown that'll pop up into existence as we're doing various actions. The other thing to point out here are the two tabs. The Tortoise HD interface lets us have two repositories open at the same time. In this case, both Bob and Carol. Bob is selected, which by the way is why it's highlighted here. If I selected Carol, that would become highlighted over here. Down on the left, and not to be overlooked, is this output log. And sometimes if you attempt an action and for whatever reason it doesn't work, you're going to see an error message pop up in that output log. It's easy to overlook, and so you might get frustrated if you try something and it doesn't work and you don't know why. Remember to look down here for the output log, and that may give you a hint, very likely tell you what's going on. Now a quick walkthrough of how we might work with Mercurial in a hypothetical product. And again, I'm going to use my two hypothetical developers, Bob and Carol. And so the scenario here is that Bob has been working on a project and he's up to revision 4. So he's got his working directory, and by the way, remember that that's going to be his, basically his Visual FoxPro root folder, my app, as in the previous example. And he's also got his local repository, which is the .hg subfolder underneath my app. So that's our starting point for this example. Bob makes some changes to Carol comes along, and Carol is now assigned to work on the same project. So she does a clone, and what a clone does is to pull the local repository from Bob's site over to hers. Now, this could be typically two separate computers. I'm kind of assuming that Bob has his and Carol has hers, and we're not concerned with the mechanism right now. This could be file system, it could be HTTP, but in whatever manner that the access has been permitted, Carol has access to Bob's repository and vice versa. So Carol does a clone, and when she does that, what she ends up with is the local repository, but what's missing? Look at Carol's area over there. What she doesn't have yet is the working directory. She doesn't have any of the source files. But the source files can be recreated from the local repository. So what Carol does is an update command, and then what that does is to create the working directory. And at that point, what Carol has is identical to what Bob has, assuming Bob hasn't yet made any changes. Now, in actual use, the update command is sort of automatic when you do a clone. There's an option to turn it on or off, but it's on by default. So this really, the last two steps are really one step in actual use, unless you change the default setting. So now let's look at Carol. She's been assigned to make some changes to this project. So she changes one or more files in the source code, and her working directory, let's say she has a PRG and it's now up to revision 5. In order to preserve those, she does a commit, and the commit creates a new change set at revision 5 in her local repository. So far, nothing has happened over on Bob's side. He's been out playing golf or whatever he's doing, and he does not yet have the changes that Carol has. But now he gets back to work, and he has to start on some changes of his own, but he knows that Carol is also working on the same project. So what he does to get started with his day's work is to check and see if there's anything coming in from Carol, whether she made any changes or not. So he does a pull from Carol's repository and finds out, sure enough, she had a new revision that he doesn't have yet. So at this point, that's what the situation looks like. Bob now has the change set that Carol created, but his working directory has not yet been updated. So his source code files are still the way that they were. What he has to do is an update command, and what that does then is to apply the change set from his local repository to his working directory and update his file so that he now has the same file that Carol does. And again, this is an overly simplified example, but given that nobody's made any other changes than the ones I've talked about, they now again are back in sync, and they both have the same files to start working from. So let's see how that works in actual practice. What I'm going to do here is flip over to a files. This is the PowerDesk that I mentioned earlier, where it's a 32-bit application. This is the one where I wanted the folders to be synchronized and the icons to show up even on a 64-bit machine. Back when I talked about the install, this is what I was talking about. So Bob's going to create a file. He's going to start on an awesome new project, and he's going to do that by creating a file. Now I'm going to use a notepad replacement instead of using Visual FoxPro just because it's a little bit faster. So Bob starts this project and he says awesome code goes here, and he's going to save this file, and we're going to put it in his folder, and we'll call it fox.prg. So we've now saved that, and if we look at the directory, I'm using Bob and Carol, obviously two folders on the same local machine here, but I want you to, pretend as though these are two different computers, one belonging to Bob and one belonging to Carol. So Bob's created the beginning of this project, but he's not yet put it under version control. In order to do that, he right-clicks. A couple ways he can do this, but one way is with the context menu. This is Tortoise HG providing these entries now on the context menu, and he can do Tortoise HG, create repository here. It'll ask one question, and that is, do we want to create the special file? I'll leave the default of yes. I'll explain in a minute what that is. The cool thing too is that in this dialog it actually shows you the command that it's going to run, HG init, and then the destination for that repository. So we'll go ahead and create that. We get confirmation that it was done, and now we can see that in Bob's folder we have that .hg local, the local repository in the .hg folder. If you want to look in there, you can. There are some things that are created automatically, and this will grow over time as we make commits, but you're never going to work with these files directly. So we're going to just look at the root folder of Bob's folder. Well, we're not quite done yet. You notice the little overlay icon here. This says that everything is in sync. We haven't yet added any files or done any commits, so let's open the workbench. This is the one we saw the slide about earlier. So here's the workbench, and let me close up these other ones that I had earlier, and we're going to look at Bob, which is what's open here. We'll select the working directory, and we can see that there are two files, and their status is at the moment unknown. And if you look over here, there's a little drop-down list that gives you the key. Question mark means unknown to Mercurial. It doesn't know anything about these files yet. What we want to do is select them. We can either do that individually, or we can use this button up here that marks everything down here all at once. We want to create a commit message. That's always a requirement, and by default or by convention, the first commit is always called initial commit. So two things are going to happen. We're going to click commit, and it's going to prompt us to add the untracked files. This is kind of a shortcut. It's kind of nice. It says, do you want to add these guys? The alternative would have been to mark them for adding individually, but we don't need to do that. So we'll say yes, we're going to add them, and then we're going to say the commit is done. And now you'll notice that we have revision 0, and we have our comment. It's also marked as the tip revision. Default just means it's in the default branch, and that's where everything is unless you create another one. So if we look at the working directory, there are no unmodified files at this point. Now let's assume Bob makes a change, and the first thing he does is to add a statement that says Fox rocks, and he'll save the file. And then if we come back to Tortoise HG and refresh, we'll find out that we now have status M, which stands for modified, on Fox PRG. So we're going to commit that change and give it a commit message, and that's going to create revision 1 up here. So now we have that. Now at this point I'm going to skip ahead using the Julia Child method, and if we can get this to work without Windows complaining about me deleting protected files, we should be in good shape. Good. And I'm going to take the little staged zip file that I created earlier and extract it over here. And then we'll take another look at Tortoise HG and see what it looks like now. Again, let me close these guys down. So we're looking at the same repository. And by the way, you can make Tortoise HG show the path or not show the path. Right now it's showing that this is kind of a good confirmation that shows that it's there. I also turned an option on that made it show the full path up here. Sometimes you're working with repositories that have the same name. It's good to know which one you're actually working with. So now we've jumped ahead 3 or 4 steps, and Bob has gone ahead and made two or three other changes. He's now up to saying Fox rocks 4 times. And by the way, if we look at the working directory, we see that there's nothing modified, but we can use the manifest tool to look at the file, and we can actually view it. I should have used edit and not open, because I think this is going to open FoxPro, but in any case, we can see that it's up to 4 times. So that's just showing another feature of the Tortoise HG tool, is the ability to look at the file history of a file and see what it looked like at any given point for that individual file in the revision history. That's kind of your time machine. That's what I was trying to talk about earlier. So now let's talk about Carol. Carol wants to get involved in this project. So Carol comes along on her machine, and she's working in her directory. Actually, I'll do it over here. And she's going to do Tortoise HG clone. And we need to change the source because we're coming from Bob, not from Carol's directory. So now we're going to clone from Bob to Carol. And again, notice that Tortoise HG is showing you the actual command that it's going to run. This is the same as if you type this in at the command line. So Carol makes a clone, and in a second it'll refresh there we go. So it knows that that's current. Now if we look at Tortoise HG, we can see Carol's repository. Notice that we now have both Bob and Carol open. And she has exactly the same revision history and exactly the same source code files that Bob has. So let's say Carol wants to make a change. I'll do kind of a shortcut way of doing that. I'll edit that file. So this is Carol's file. You can see we're looking at Carol's copy here, and she's going to change that to 5 and save the file, and then it should show up as modified now in the commit dialog. We'll refresh it, and in fact it's modified, and down here we can see that she changed it from 4 to 5. So she'll create a commit message and commit that change. She now has revision 5, and everything is fine. Bob, on the other hand, is still sitting at revision 4. So what he needs to do is to pull the change from Carol back over to his folder. And a couple of ways he can do that. What we'll do here is to use Tortoise HG's sync dialog, SYNC, and the only thing here is that it doesn't yet know about the location of Carol's directory. Carol knows about Bob because she cloned from him. Bob doesn't know about Carol yet. So in order for him to pull from her, he has to know, or his entries have to know how to get at that. And here's a trick that kind of works pretty slick. If you bring up a file, a Windows Explorer window, you can drag a folder icon to this entry and plop it in there without having to type it in. So I just did that. It works from my PowerDesk as well as from the actual Windows Explorer. And then we'll save that, and we'll give it a name. And now that's been saved down here. So now Bob has a link to Carol, and what he can do here, and this will be the previewing action, is he can ask Tortoise HG via Mercurial to tell him, is there anything that Carol has that I don't have yet? And so he'll check for incoming changes. And what he'll find is there is one incoming change set. He now has the option to accept it or reject it. The commit message that Carol used is important because it kind of tells Bob what she did. And now he knows he needs that change. So he'll accept it. And this is kind of that filter dialog or message dialog I was talking about that pops up from time to time. I'll close that. So now this is what Bob's repository looks like. So what's this scary looking message here? Not a head revision. It's in red. It's got an exclamation point. Is that an error? Now the answer is no, it's not an error. It's just an alert. What it's telling you is that the working directory is based on revision 4. That's why it says 4 plus. And 4 is no longer a head revision because 5 is the child of 4. 5 was derived from 4 by Carol. So in order for Bob's working directory to get the update that is now in this change set, he has to do an update. And by the way, this is not a merge situation because there are not two heads in the repository. That's a little more involved example I'm not going to go into tonight, but in this situation, you would either typically do an update or a merge after you do a pull. In this case, it's just an update. So we'll update to 5 from 4, and once we do that, then Bob and Carol are back in sync, and if we look at the file, we can see that it now says 5 times in Bob's side as well as in Carol's. So I hope that was useful. I know it's a little bit long-winded, but I wanted to actually do an actual practice what I had showed you in the slides. Let's see if I can get back to those. That was this slide. That was the end of that example. We've now done exactly that in actual use. So I hope that was useful. There is a situation that can easily arise when you're doing this kind of work, even if you're working as a solo developer on different branches. But certainly if you're working in a team environment where you're sharing changes with other developers, and that's the concept of a merge conflict. So think about that line. Line 2 of our code was for I equals 1 to 5. Now let's suppose that Bob makes a change and he changes it to 10. But independent of Bob, Carol comes along and she makes a change and she changes it to 7. So that's all well and good. Bob's exists fine by himself and Carol's change exists fine by herself. But when they go to merge their changes together, you get a conflict because the same line of code has a different change in the two change sets. And so Mercurial detects that and provides a mechanism for resolving it, and it is, in fact, the command is called resolve, and it can be done from within Tortoise HG. And basically, this is the three-way merge tool that you may have seen other examples of. There's one built into Mercurial. I prefer to use Beyond Compare, which has a fine three-way merge tool built in. And basically what Mercurial is saying in a merge conflict situation is there's something going on here that I can't fix. You, Mr. Developer or Ms. Developer, need to get involved and figure out what to do. So in a case like this, you'd either keep it at 10 or at 7, or you might compromise and make it some other number. But that's what a merge conflict would be. When we're working with Visual FoxPro, we have some special considerations. One of them is what to include in the repository. The obvious one is the PRG files. Those are our source code files, our text format files anyway. But in addition to that, think about all the binary source code files. Class libraries, menus, forms, reports, labels. Think about the project file, which is also binary. Think about all the things in your project folder. DLLs and FLLs you might have, image files, help files, configuration files, compiled files, database files that you might reference in the project manager, backup files, just a whole host of things. So which of those do we want to include in our repository? Well, in order to answer that question, you've got to consider that there's two kinds of files. There are text files like the PRGs and the .inis and the .h files, and there are binary files, which is basically everything else. Visual class libraries, forms, and reports primarily that we're interested in. The key difference with respect to version control is that text files can be merged. You can look at two text files side by side using a three-way merge tool, or even just a side-by-side compare tool, and see what's different. You can't do that with a binary file. You not only can't see a meaningful difference, but you can't merge them. So binary files are problematic. And that's the 800-pound gorilla in the room what do you do about your binary files? How do you handle that situation? And Visual FoxPro is kind of unique in that respect because a great deal of the source code in any project is typically in binary files. Well, the answer is you convert them to text. I think everybody knows about the SCC text file that comes with Visual FoxPro that creates the SCA and the VCA files. There's also a wrapper class that Matt Slay wrote that is kind of nice for handling that sort of thing. There's also the SCC Text X, or alternate SCC text tool, which is a VFPX project. The problem with all of those is that they're only one way. And for really effective use with a version control system, you have to be able to convert not only binary to text, but also back to binary again. In other words, you want to convert to text in order to commit to the repository to do merges and comparisons, and then you want to go back to binary so you can use the Visual FoxPro IDE to make your changes. The only tool that I know of that does that is 2Fox. That's Christoph's tool. And if you're not familiar with that tool, you can download it either from his website at foxpert.com or more recently from his shared repository out on Bitbucket. Christoph is actually using Git for that repository, but it's conceptually very similar to Mercurial, so it's you can get it from there as well. What I found is that he's putting the more recent versions up there on this Bitbucket shared repository, and that may be where he keeps going with the more recent ones as he goes forward, rather than updating the one on FoxPro. So that's the link, and you can download that. But even with that, you have the question of whether or not you want to include the binary files in the repository. I wish this was interactive, because I always like to ask people at this point, you know, if you're using version control, what do you do? Do you include your binary files or not? And when I ask that question, a lot of people say, yeah, they include the binaries even if they're using a binary to text file. Well, the advantage of including the binaries is that if you're going to let somebody clone the repository, they get everything they need all at once without having to have the same tool that you might use to go back from text to binary. The disadvantage is binary files are big. As we said before, they can't be merged. And so your change sets, including all of those big binary files, is going to be increasingly large over time, more so than if you didn't include the binaries. If you decide to include them, all you have to do is add them just in the same way that we added the PRG file using Tortoise HG. If you want to exclude them, we're going to use this hgignore file, which is Mercurial's mechanism for telling Mercurial what to exclude. It kind of works the opposite direction. Instead of saying what to include, it says what to exclude. And the hgignore file is a simple text file. It looks like this. This is a sample one, but it's pretty much what I use. It's simply a list in normal syntax where star dot and some extension will be a group of all of those kinds of files. The only thing that's unique about it is that it's case sensitive. So you'll notice that, for example, here we got each of the entries twice, once in lowercase and once in uppercase, to cover all the example or all of the possibilities. The third issue with Visual FoxPro is what happens when you recompile everything, which is a good practice. You always want to do that before you do a release. So when you do a recompile all, what happens? Well, here's our beginning state, and if you look at the icon overlays here, all of the things that are being tracked, you'll notice the green check mark. All of these files are in sync, they're current, the repository is up to date, there are no uncommitted changes. If we change just one file, suppose we change readme.txt down here and rebuild our app and do a recompile all, then what happens is a bunch of other things also change. Specifically, forms, menus, the project file, the report file down here, all of that stuff changed. Well, the reason for that is that the program or the files got rebuilt when Recompile All was done, so Mercurial detected them as a change. There isn't really anything you're going to be able to do about this. If you include your binary files in the repository, you're going to just have to deal with this. And it's not really anything you have to be overly concerned about. It just means that your commit is going to include a bunch of files that you didn't actually make any changes to. but that were changed by FoxPro when you did the Recompile All. It's just something to be aware of. Mercurial is not case sensitive. Actually, I should say it a different way. Mercurial respects the case sensitive nature of the operating system that it's running on. So on Windows, which is case insensitive, Mercurial is also case insensitive. That means that a program called FoxPRG lowercase or uppercase or mixed case is the same as far as Mercurial is concerned. And that's good because that means you don't have to worry about those two being handled as different programs. Final issue that you might be thinking about is integration with the project manager. And you know that the Visual FoxPro, as it shipped back with 6 or wherever it was that it was first included, allowed you to integrate with Microsoft's source control system. But with Mercurial and others like Git, the answer is just simply no. You're not going to integrate this with the project manager. So those are some things to think about when you're working with Mercurial. We'll start to wrap up now by looking at workflow and a couple of other things to take us to the end of the session this evening. When you're working without Mercurial, you're going to be going through the typical code test debug cycle. So you sit down, you write some code, you test it, you debug it, you go back and you code some more. You go round and round in this loop, and at some point, and while you're doing that, you're making changes to what we would now call the working directory, since we're talking in Mercurial terms. And at some point, you make a backup of that. And that's all there was to it. That was your workflow, basically, without a version control system. When you add Mercurial into the loop, you're going to create the repository. We already saw this by way of example. And you're going to add files. Remember, we did this back in our example. We added the files here. This one has more than our example did, but it's the same idea. And then we're going to commit those. And when we do that, then conceptually what we've done is to create this local repository and commit our changes to it. Now here's an interesting thing. Because the local repository is a subfolder of the working directory, when you do a backup, you get both, assuming you're backing up the working directory and all of its subfolders. So in addition to your PRG and your classes and your include and your reports subfolders, you also get your .hg subfolder. That's good and bad. It's good in the sense that you've got a copy of it, and you can't have too many backup copies. It's bad in the sense that if you're working with a remote repository, somebody else is on the team, or you're using a central repository, and you restore from an earlier backup, and you restore the local repository as well as the working directory, you can create a situation where you're out of sync with the remote. You've actually eliminated some of the revision history that should be there. So you have to be kind of careful if you're going back and restoring from a backup. It's a mental shift, starting to use a version control system rather than your old familiar backup system. If you throw a remote repository into the mix, then you're doing pushes from those changes up to the remote repository as well. And at the same time, you're probably pulling changes from the remote repository back to the local, and then from there you're updating and or merging back into your working directory. So the point of these couple of slides was to consider that your workflow will change when you're using a version control system, and you just have to adapt to that, and you have to remember to do all of the steps that are involved in order to use it effectively. A word about remote repositories, and again, that's nothing fancy, that's just any repository other than your local one for the same project. It can be on a hard drive, whether it's internal, external, or network shared. It can also be a cloud drive. I use Jungle Disk, and I've used it successfully now for over a year, which maps as a J drive on my local file system, and I have a central repository out there. It works just fine. I'm not sure I would be comfortable using Dropbox or similar products. Dropbox is a fine product. I use it all the time. But as a place for a repository, I'm not sure it's a good idea because of the way that it is automatically updated whenever you make changes. And if you have 2 or more people doing that at the same time, might be problematic. I haven't tried it, don't plan to try it, but just a word of something to consider there. Mercurial does come with a built-in server. There is a lot of documentation on this available online. If you want to fire it up, you get at it through the port 8000 on localhost, and you can play with that. You can also do what I would call private hosting, either on Linux or Windows, where you can configure your own repository. The only article that I know of that talks about setting up a Mercurial server on Windows Server 2008 specifically is the one I've linked to on this slide. There's also what I would call public hosting. That's not to say that it's open to the public, that your repository is open to everybody. It's just that it is a public service that you can subscribe to. This one is Bitbucket. It's certainly the dominant one for Mercurial hosting, and you can create a repository out there. I think Bitbucket is free for up to 5 projects. I may be wrong on that. I know it's free up to some level, or at least it was, and beyond a certain level, then it's a paid product. But that's certainly a cloud-based service that you can use as well. If you're working on a team, there are a couple of ways that you can think about collaborating with your other team members. Again, keep in mind that, again, here are our 2 developers, just representing 2 of the possible whatever number are on the team, each making their own changes and sharing the changes among them directly. And that would be what you might consider the least control situation. That's kind of the unmanaged. There's no boss. There's no one single version of the truth. If you want to implement a little bit more control, you might consider using, sorry, I missed a name there that's sometimes referred to as informal anarchy. If you want to use a central repository, you can implement a little bit more control where each developer pushes changes up to and pulls changes down from the central repository, but might also continue to share changes among themselves directly as appropriate. If you want to go to maximum control, you can eliminate this step and say, just by business policy within your group or your company, that everybody will use the central repository only and will not share changes directly among themselves. So different ways that different groups might decide to work, whatever is most effective for their situation. One final comment, and this is an answer to a question that actually came up one of the first times I did this session. Consider, again, Bob and Carol each with their own local repositories and working directories. And now we throw a central repository into the mix. So here's the local repository. It's local with respect from the point of view of the central. Let's say that it's on a file server somewhere. So it's an F drive. Nobody does development work on the F drive. So Bob and Carol both interact with the central repository by pushing and pulling. But the thing that's different is that there is no working directory on that central repository. And that question, somebody had looked at their F drive and said, well, where are all the files? Where are all the source code files? Well, the answer is you don't need them there. Because the only thing you need on the central repository is the revision history, all the change sets. And the working directory can always be derived from there. So since nobody is actually working on that file or on that server using it as a workstation, there is no working directory. Quickly avoiding trouble. This is the biggest tip I can give you as a VFP developer. Close the project manager before you do anything else. If you don't, you won't be able to complete a commit or any other action, and you might get that little warning I told you about down in the output log. Previewing is a good idea. What's going to be added, what's going to be ignored, so you know what to expect. On remote repositories, use the incoming and outgoing commands in order to know what's about to happen. If you expect one change and you see you're going to get 6, you might stop before you accept those and find out what all is going on. Similarly, if you're expecting to push 1 and it's going to push 10, you might want to stop yourself and ask what's happening there. Updating after pull is something that is easy to forget. If you're using Tortoise HG, it's default to do that, so you don't have to do it explicitly. But if you pull and don't update, your source code files do not reflect the changes you just pulled into the repository, and that can also be a source of confusion. So that's it, folks. Just to summarize, we talked a little bit about why we would use version control, how to install, configure, and work with Mercurial, some ideas about using it with Visual FoxPro, a little bit about remote repositories and where they can exist, how to interact with them, a couple of thoughts on team development strategies if you're working with a team of developers, and a couple of tips on staying out of trouble. For further resources, here's a short list, a couple of books, actually one book available both in print and online, a couple of resources on the web. The hginit.com, the one from Joel Spolsky, has been around for quite a while, but it's still pretty good. It's a nice introduction. And the email listserv that I referred to earlier is very active. It's called Tortoise HG Issues, but it also gets Mercurial comments, and you can subscribe to that. Be prepared for a large number of posts to that listserv, even more than on the FoxPro listserv, or ProFox, I mean to say. There are also a couple of white papers that I've written for past sessions at conferences, and you can find those at my website, ita-software.com. Go to the developers page, which is foxpage.aspx, and find the white paper section. You'll find 2 white papers on using Mercurial with VFP. That's it. Thanks. I'm on Twitter at Rick Borup. Please feel free to connect there. I'd look forward to hearing from and talking with all of you. Todd, that's it. I think we're done. Thank you.
Can you explain a little bit about how the 2Fox works into the workflow?
Yeah, sure. What 2Fox does is to create XML files. That's the text version that it happens to use. And so before you commit changes, you would use 2Fox to generate the XML files from the binaries. So any change you made to, let's say, a screen file or a report file or a visual class library, let's say, any of the binary files, 2Fox would create an XML file equivalent of that. XML is text-based, so it can be merged, and you can read it, a person can read it, unlike a binary file. So you would then commit the XML files to the repository. Whether or not you also commit the binaries is up to you. That's kind of the question we talked about earlier. But you would at least commit the XML files. On the flip side then, when you pull changes back down from a repository, you would pull the XML files, and you would compare those using a merge process with your XML files for the same file. In other words, you have an XML for your version of fox.prg, and there's another XML file that represents the change set for that same file from the other repository. And you can use the standard 3-way compare and merge tool on the 2 XML files. And it's not quite like reading straight PRGs, but you can see where the differences are, and it's not very difficult to merge. Once you've done the merge, then you generate the binaries back from the XML, and then you have your VCX or your SCX or your FRX that you can work with as you normally would. Does that answer the question?
Yeah, so when you're going to commit, you've got an extra step of having to run the 2Fox first.
Exactly.
And then Mercurial is going to see all of those changed files. The XML are going to be the actual changed files then that you're going to be committing back.
That's correct. And in fact, if you choose not to include the binaries, that's the only changes that Mercurial will detect. So that's kind of nice and clean, because then you're not dragging all of the binaries along with you.
Right.
But in order to get to that point, you have to have full faith and confidence in the ability to recreate the binaries on the other side.
If you're working independently, you're not going to end up with conflicts, are you? That you're going to have to resolve?
You can, and the way that can happen is if you use branching to work, for example, on a feature development while at the same time maintaining a release version of the source code for the same product.
Right.
And so you can, in fact, end up with merge conflicts based on changes that you've made in another branch that you then bring back into the release branch.
Right. So what does your day-to-day look like then? Are you committing multiple times during the day? Once a day? Is it once a week? Depends on how big of a change you're making.
Multiple times a day, typically.
Yeah.
It depends on the amount of work. I always commit and push to my remote repository before I leave the office, whether it's for lunch or for a break. It's part of my disaster recovery thinking that, I don't want to be caught cold and lose even a half a day's work. So it's just part of my normal workflow. It doesn't take very long. I actually maintain 3 remote repositories. Now, I'm working as a solo developer, so I'm not collaborating with a team, but I push changes up to 3 separate remote repositories kind of as a backup. One of them's in the cloud, and that allows me to pull stuff down when I get home and I work on my laptop back there. The other two sort of serve as a backup and a way of sharing files between the 2 or 3 machines here in my office.
If that .hd folder has got all of your iterations of everything you've changed, it sounds like that's going to become a huge amount of disk space at some point.
It can get pretty big, yes.
And then is there a way, I assume, to clear that out at some point, or to say, you know?
Well, I've never found it necessary, and I don't think you'd want to. I mean, if you do that, you're going to lose all your history.
Right.
I suppose you could back it up somewhere, archive it, and then start over again. But in my experience, and I've been using Mercurial for a couple of years with more than one actively maintained product, and I've never gotten close to even thinking about wanting to blow it away and start over for size reasons.
So
It's not really an issue. I mean, disk space is not that precious anymore.
right. Have you gotten rid of then your backup of, you know, grandfather, father, son backups?
Yes, I have.
You just back up just that, what, just the .hg?
I back up the whole, well, yeah, I back up the whole thing, but I don't use generational anymore.
You just
I still do a full machine backup, part of the disaster recovery
Right.
scenario. I also occasionally do a full backup of my project folder, but again, you have to remember that you're never going to restore from that. You might cherry pick from it if a file got corrupted and you had no other way to get at it. That's kind of why I do it. But you got to be real careful never to restore the local repository from an old backup, or you're going to mess things up with respect to the other remotes that you're interacting with.
You're going to mess the whole thing up.
Yeah.
And then realistically, how many branches do you ever have going at the same time?
I have one for each release version of the product and one additional for any major feature that I'm working on. If I start a change for a small fix, because I'm working solo, I don't feel it's necessary to create a hotfix branch all the time. But for a significant feature development, I would embark on a new branch, because the risk is that if you don't and you get, you know, halfway done with the new feature development and then a bug comes up in the release version, you know, you have to be able to maintain that release version independently. So it's convenient to create a branch for feature development until the feature is done and then merge it back in. So, you know, I would typically have, again, one for each release version of the same product, which might only be one, by the way. I mean, I'm talking about a major version like version 1 versus version 2, not a point release within that. So a branch for each of the major versions, if there are more than one of them out in the field, and within the same repository, just tags for the different releases,
Yeah.
1.0.1, 1.0.2, etc.
Okay. Those are the questions on my mind. Anybody else?
No, but I want to thank you, Rick, for doing this tonight. I caught your presentation at Southwest Fox, and this kind of filled in a few little holes I had in figuring out how it all fits together. So thank you very much.
Well, you're welcome, and thank you for the comment. I'm glad you were able to be at Southwest Fox.
Never miss.
Excellent.
Great. Yeah, thanks, Rick. That was very helpful.
Great. Thank you all.